Hello and welcome to helpyourmath.com. In this video, we are going to look at more applications of direct, indirect, and joint variation. We might want to recall that direct variation, we can use the formula y equals k times x. So we say y varies directly with x. In indirect variation, we would say y equals k over x. And joint variation, we add a third variable z, where we say z equals k times x times y. Okay, let's take a look. First up, we want to write a mathematical model that represents this statement. M varies directly as x squared. We're told m is 18 and x is 3. Okay, so varies directly, we know that we're looking at y equals k times x. Now, in this case, we don't have a y, we have an m, but that's okay. What we need to figure out is that constant of proportionality, right? So we're going to say 18 equals k. Now, it's not x, it's x squared. So actually, we want to use y equals k times x squared. I'm going to plug in 3 for x. And now we want to get k by itself. So I would say 18 equals k times 9. Divide both sides by 9. And we figure out that our constant of proportionality is 2. Awesome. But we still have to write the model. So we're going to say m equals 2x squared. And that would be our final answer for this first example. Up next, we're told that g varies inversely as x. So this is inverse. This time we're looking at y equals k over x. And based on the information we're given, I would just say, instead of y, we're going to replace it with g equals k over x. To me, I would say k is 1. And so then I would just say, well, in this case, we're going to have g equals 1 over x, and that would be my mathematical model. In this example, we have our first example of joint variation. E is jointly proportional to m and v squared. So now what we're talking about is z equals k times x times y. It's just, of course, we're going to replace z with e and x with m and y with v squared, right? So we're going to have e equals k times m times v squared. And then we're going to plug in what we're given. We're given 24 equals k times 3 times 4 squared. Order of operations says we're going to do this square first. So we just want to clean up this right-hand side so we can figure out the value of k. 4 squared is 16. And then 3 times 16 is 48. So we have 48 times k. But I want to know what k is, so I'm going to divide both sides by 48. And it turns out that 24 over 48 is 1/2. 24 is half of 48. So k, our constant of proportionality, will be 1/2. That's part 1. Part 2 is we're going to write the model. We're going to say E equals 1/2 times m times v squared, and that would be my mathematical model given this information. So far, so good. Let's keep going. Next up, we have z varying directly with x and inversely with the square of y. Okay, so directly, we're going to say z equals k times x, but inversely means that we're going to have a denominator of y squared. So we're starting out with this setup. We need to figure out first what k is. We're told that 6 equals k times 2, and then in the denominator, we'll have 3 squared. Cleaning up the right-hand side again, that's 2 times k divided by 9. I want to get k by itself. It's being multiplied by 2/9. So I'll multiply both sides by 9 over 2 because that way the 9's cancel and the 2's cancel on that right-hand side. And I'll multiply the left-hand side for equality. I like to simplify before I multiply. I have 9 times 3. It turns out in this case, I'm getting k to be 27. So I have my constant of proportionality. I'm ready to set up the model. We're going to say that z equals 27, and we're going to say z equals 27x over y squared. And we're going back to putting in our variables as they're given. So that way now we can plug in new variables and get, different variations as we go. In our next example, we have p varies directly as the square of x and inversely with y. Okay, so this one we're going to say p equals directly, so we're going to have k times x squared, and inversely with y, we'll put a y in the denominator. And now we need to figure out first what k is, and then we'll set up the model itself. We're told that p is 3 when x is -1 and y is 4. Cleaning up that right-hand side, we get 3 equals, well, -1 squared is just 1. That would be k over 4. I'll multiply both sides by 4 to clear out that denominator of 4. And I get that our constant of proportionality is 12. Now to set up the model, I'll say p equals 12x squared divided by y. And there we have it, the representation for this example. Last up, we're told that q varies jointly with t and s and inversely to the square of w. So now we've got a lot going on here. We have 5 variables because we also have the variable k. So to start this out, just to kind of set this up, we have q equals t times s times k and inversely to the square of w. So that's going to be our initial setup. Let's figure out what k is. We will say that 2.5 equals 1.6 times 4.3 times k divided by 1.2 squared. So far, so good? Okay, great. This is the first one where I might want to use a calculator because this is not math I necessarily want to do on my own, although you're welcome to. So let's pull up a calculator. Okay, so I have my calculator pulled up. Let's clean up the right-hand side. I'm going to say 1.6 times 4.3 divided by, and I'll put it in parentheses, so I'm only squaring the 1.2. And then I can hit enter and I get, let's turn this into a fraction, 43 over 9. Of course we get 43 over 9. Okay, I'm just double checking my work, 43 over 9. And then we'll write here 2.5 equals 43 over 9 times k. To get k by itself, I'll multiply by the reciprocal of 43 over 9. So it's going to be a 9 over 43 on the right-hand side and a 9 over 43 on the left-hand side. And one more time, just to get a nice fraction value for k, I'll probably plug this into the calculator. And I'll say 2.5 times 9 divided by 43. I want this to be a fraction, and I get 45 over 86. So k is 45 over 86, and we have our constant of proportionality. Let's put this back into the model. Let's create this model. We're going to say q equals 45 in the numerator, 86 in the denominator, times t times s in the numerator, and a w squared in the denominator for that gorgeous mathematical model. These have been examples of setting up direct, indirect, and joint models given certain information. Thank you for stopping by.